Okay guys, today we'll be looking at standard operating procedures for surface water sampling of creeks, rivers and dams. A copy of these procedures is available in the comment section of the video, and the procedure is just an outline of the presentation I'll be giving today. So firstly we'll have a look at the purpose of these procedures. We'll move on to safety factors of sampling surface water, including accessibility to this location site, and we'll also have a look at personal protection equipment. We'll then have a look at the procedure, sampling method. We'll have a look at factors affecting sampling, quality control samples, types of different sampling containers, and then I'll demonstrate how to take a water sample. And finally we'll finish off with talking about correct method of transportation and handling of water samples. So we'll have a look at temperature and chain of custody. So firstly, if you go over to the second page, we'll have a look at the purpose of these procedures. These procedures provide a guide for the collection, preservation and handling of surface water samples. These general principles are to be applied in sampling for physical, chemical and microbiological analysis of surface and waste waters for the purpose of quality characterisation and identification of pollutant sources. The following standard procedures are in accordance with current Australian and New Zealand standards. Okay, so basically these procedures will be used by field technicians carrying out this type of work, and the idea of it is to create uniformity in their method and hopefully increase the accuracy of their sample data. Okay, so firstly we'll have a look at the safety aspects. Field technicians collecting surface water samples are exposed to a variety of health risks. Prior to any water collection, a site must be visited and analysed for potential hazards. A safety plan document must be prepared prior to every site visit, outlining all hazards, risk likelihood, severity and action of control. So if we have a look at site accessibility, it is a crucial factor when determining a sample location. Factors including rough vehicle terrain, uneven stepping, bank steepness, density of bushland, flow rate, depth and aeration of surface water, and reaching for a sample are all determining factors in the selection of a suitable regulatory sample location. Often a sample location will be determined by the client to comply with a regulatory licence condition. In this case, a heightened risk may be controlled with an alternate method of sampling or the use of PPE. So if we have a look at the PPE, field techs will require to use disposable gloves to help protect for bottle preservatives, eyewear also, lace up steel cut boots for prevention of slipping over, and long pants and long sleeve shirt. Okay, very common in most mine sites and industrial sites. On top of this, a life jacket can also be used, and highly recommended when working alone or when a heightened risk situation has been identified. A sampling pole can also be used for inaccessible sites, but we'll talk about contamination issues with that later in this procedure. So if we move over to the actual procedure, we'll have a look at factors affecting sampling. The following factors should be considered by field technicians when preparing a sample for any new site. These factors are outlined in section 4 of the Australian New Zealand standards and are capable of influencing water quality at a given location. So I've just listed a few here. This table should actually be addressed for all of them. But flow rate, depth characteristics, combining of point sources upstream, seasonal fluctuations, and biological or chemical hazards. So all these things should be considered before filling out your sample plan. Next thing is quality control samples. These components explained below are essential requirements of any sampling plan. They are designed to ensure the accuracy and precision of the monitoring and may be used to determine the validity of specific sampling and analytical procedures. Clients will often ask for QC samples, however laboratory analysis of duplicate samples is often expensive. So firstly we have field blanks. So these are just a sample of deionised water, and it's treated as exactly the same as a normal sample, and the idea of this is to identify areas of contamination in the sample collection and analysis. They also have field duplicates. A duplicate sample can be taken at the sample site at the same time, and it's by the same person. So a field duplicate are used to test the accuracy of laboratory analysis. Then there's also external field duplicates. It's similar to a field duplicate, however the sample is taken by an independent person. Same site, same time, however it's used to examine the precision of the sample. And then the last one is spike samples, and that's when a known concentration of the parameter being measured is added to the sample, and this will increase the concentration by a predictable amount. It is used to test the accuracy of the method. Frequency of the samples is basically determined by the client, and it'll be included in the sampling plan before any water sampling method is taken place. And it's usually regulated by license conditions involving collection time, frequency and parameters to be analysed. It'll all be in the sampling plan. Sample container selection. I've got a few different samples container here provided by ALS. The preservation of a sample is highly dependent on the selection of sampling container. Some containers may contain chemical preservatives designed to prevent reduction or loss of the target analytes through physical, biological or chemical processes such as precipitation, adsorption or oxidation. The type of container is also important, choosing plastic or glass, and acid washed or solvent washed is necessary to reduce a loss of target analyte and prevent organics such as hydrocarbons remaining on the sides of the container. So for example, you can see this glass jar as an alternate to plastic for the sample of oil and grease, and prevents the analyte sticking to the sides of the bottle when at the analysis at the laboratory. Some analytes require tinted containers also, designed to reduce the exposure to sunlight. The holding time of samples containing some inorganics such as chlorine can be significantly reduced when exposed to light. Table 1 of the Australian New Zealand standards can be addressed for a complete outline of sample container requirements. So different type of samples. There are three main different types. When selecting a sample method, it is important to consider the desired objectives of the sample plan. Examples of different techniques are discussed below. So here we've got grab samples. That's the most common type of sample method. This technique is a sample taken at a particular location and is only representative of the water quality at that time. So basically go to the site, take a sample, and the analysis and data you get from that is representative of the conditions of the water at that time. Composite samples. Samples collected through multiple grab samples to collect an average water quality characteristic over a selected time or flow interval. Composite samples may be used when the distribution of constituents within the stream are random, increases the temporal and spatial extent of sampling. So composite samples, you take a different sample along a section of a river, you combine the sample to make a homogeneous sample, split it up, and it increases the spatial and temporal variation of the site. The last one is a series sample. It can be collected across a given area or depth to create a profile across a target volume of water. So the most common one will be the grab sample, and that's what I'll be demonstrating today. So sample collection, we'll just read through this now. So prior to leaving for site, first thing is to fill out a risk assessment and review all the hazards. Obviously if there is a hazard that can't be controlled, then work cannot be carried out. So you need to ensure firstly that the PPE is all available, all sampling containers, field sheets and cleaning equipment sufficient for the sampling plan are packed, and all equipment necessary for required transportation is available. So things like an esky and ice. Once you get to the sample location, we'll note the conditions of sampling location on the field sheet. Ensure all equipment entering the water body is contaminant free. Between sites, wash all equipment with phosphate free Decon 90. Then rinse with tap water, followed by rinsing with deionized water. That's a very important step because we don't want to contaminate the sample, therefore we'll get unreliable data. On the container we record sample ID, job number, date and time, and the sampler's initials. We take the sample, filling the container depending on the target analyte, and then transfer these samples into an SCI on ice, fill out the completed chain of custody, and we need to take that to the laboratory within the analyte's holding time. Okay, so now I'll demonstrate the correct method. For an example, say SCIT2100 requests a sample at the university for temperature, dissolved oxygen and pH. Choosing our container, we choose a green label. We can see on here that there is no chemical preservatives, which we don't need for those target analytes. And for those three analytes we need a litre or volume of water. So we've got a green label, litre volume, and the correct method is to record our details on the label first. So client and reference, SCIT2100, that's who we're sampling for. Sampled by, put my initials, AB, Angus Brown. Sample ID, we'll have license discharge point 1 at site X, and date and time, we'll have 10 o'clock on 21st of the 10th, 13. Okay, so I'll just show you that. So client reference, SCIT2100, sampled by Angus Brown, LDP for license discharge point at site X, and our date and time. Okay, you can also see here example of target analytes, and usually here they would have any chemical preservatives. If we have a look at another one here, we can say sulfuric acid, and it has a quick list of MDMS. So if we wanted to also test for nutrients, fill this out, sulfuric acid, purple bottle, we'll fill both of these bottles. They've also requested metals. We can do tests for dissolved metals or total metals. Fill out the same details along here, however dissolved metals must be filtered, and we need to tick one of these. SCIT2100's request for a filtered dissolved metals sample, so we'll also be sampling with this bottle. Okay. So these are our 3 bottles we've all filled out with details. These 2 containers contain chemical preservatives that we do not want to lose. So we must decant from our larger bottle into these 2. So filling up with this, we'll fill up water by holding at the base of the bottle. Upside down we plunge into the water, slowly tilt it upstream, fill the water bottle. Don't fill it all the way up to about here. From here we decant into the bottles with preservatives in there. Same for our nutrient bottle. Again, upside down, plunging beneath the surface, make sure we're not picking up any scum or algae. Slowly tilt it upstream to fill the bottle and release all the air. And these 3 samples can be placed in the SCI on ice. Okay, now if we wanted to sample dissolved metals, the sample needs to be filtered. So for this, it requires a 50ml syringe and a 50 micrometer filter. The filter screws onto the end of the syringe. Using our large unpreserved bottle, we fill up the syringe. Now we've ticked dissolved metals, field filtered, so the laboratory knows that it's already been filtered. from there we pass through the filter, so we're only collecting the dissolved metals. To tick total metals, the filtering wouldn't be required. Okay, so transportation and handling of samples. We'll first discuss the temperature. Immediately following sample collection, samples containing analytes that require chilling must be packed on ice or refrigerated and maintained above frozen temperature and below 4 degrees Celsius. Glass containers may be placed in foam sleeves before packing on ice, and ensure analytes sensitive to light are collected in tinted containers and are noted on the chain of custody. So here I've got an example of a sleeve, a tinted container, glass, that can be placed into there, into our SCIT. Packed onto ice, and that can be taken to the laboratory and within our holding times. A chain of custody. A chain of custody is a legal documentation that gives confidence that the sample integrity has not been compromised. The document is a record used to trace possession and handling of a sample from the time of its collection through to its analysis and disposal. The sampler must complete the chain of custody, and this original document must stay with the samples. A copy of this documentation with custody details should be sought from the laboratory to confirm receipt and appropriate transfer of the product. So a list of all samples that I've taken on that day is written onto the chain of custody. It's in the SCIT with the samples. It's packed with ice. I take this to the laboratory. I've signed it. I give the samples to the laboratory. They give me a copy of the chain of custody, and I need to keep that and add it to our reports.